Hello, Algebra. Welcome to Chapter 8, Graphing Quadratics. Yay, Graphing Quadratics. So I'm actually taking the first two lessons, 8.1 and 8.2, and we're going to kind of combine them together, all right? Our essential question is, how do we graph and use quadratic functions of the form f of x, remember f of x is the same as y, it means the same thing, right? So f of x equals ax squared plus c. So this is one form of quadratic equations, ax squared plus c. So we're going to look at what we can tell about an equation from this setup. So we're going to be using Desmos today. Hopefully if this all works out right, you'll see a picture of the Desmos screen along with our notes. And you will want colored pencils, all right? You can see I have many colors here. Color is extremely important with this one, okay? So, first of all, we are going to use Desmos to sketch all the graphs. They don't have to be perfectly exact, but Desmos is pretty nice because it will tell you the points on there, and so you can really see and look and be accurate with it, which is nice. So, we're going to start with our f of x equals ax squared. Right? F of x equals ax squared. We want to do graphs for when a is 5 and negative 5. So I'm going to use my red and do those ones. So when I plug in 5 for a, that means that I have an f of x equals 5x squared. And taking a look at Desmos, that shows me that I have my vertex at the origin at 0, 0. And then my next point, when I move my cursor onto it, is at 1 and 5. So this is my next point. I also have a nice pretty star point. Remember our star points? I know, they come back. Isn't that great? I have another pretty star point at negative 1, positive 5. So now my little sketch is going to look something like this. Make sure that you have a curve at your vertex here, all right? It's not a point, it's a curve. It's a curve. It's just a very narrow curve. So now let's do our negative 5. When I change my a value to a negative 5, my vertex hasn't changed at all, but now I have a point at 1 and negative 5, so it's down here, and a point at negative 1, negative 5. So let's think about what just happened when we switched from a positive 5 to a negative 5. Oh, let me scroll up a little bit. There we go. I've got my points here at 1, negative 5, and at negative 1, negative 5. What happened when we switched, when we changed? Yeah, we went from it going upwards, right? It opens upwards to opening down. That's interesting. All right, let's take a look at our next one. I'm going to switch it up and use green now. So we've got an a value of 10. So I'm changing my a to a 10 here. I see that my vertex is still at 0, 0. But now my point is way up here, right? It's off the chart at 110. I did not even give myself enough room. So I'm just going to draw something like this. It's super skinny. Super skinny. So this is an a equals 10. And then down here, when I switch this to a negative 10, my vertex is still at 0, 0. But now it's going super skinny, way like this. Remember, make that vertex there curved, not pointed, but curved. So this one is an a equals negative 10. Right? We've got our a equals 5, a equals 10, negative 10, excuse me, and then a equals 10, and this one is the a equals 5. So let's try a blue next. And we're going to do an a of 1/2. So if I change my a value to 1/2, what do we have? Well, my vertex is still here at 0, 0, but now the first point is at 1 1/2. The next point is at 2 and 2. And then the next point is at 3 and 4.5, so right about there. If I look at the negative x side, then I'm at -1 and -0.5, -2 and -2, and then -3 and -4.5. So I'm going to connect my points with a nice curve. And this is with arrows on the end, right? It goes edge to edge, arrows on the end. So this is a equals 1/2. That's what my graph looks like for a equals 1/2. So I'm going to slide my paper up, and let's take a look at the -1/2. My vertex is still at 0, 0, but now I have a 1 and a -1/2. I have 2 and -2. I have 3 and -4.5. So it looks something like this. And I have -1, -0.5, -2, -2, and then -3 and -4.5. So that is for my a equals -1/2. All right, the last one I'm going to do, I'm starting to run out of colors, so I think let's stick with orange. We have our 1/5, all right, 1/5. So my vertex, when I plug in 1/5 for our A, my vertex is still at 0, 0, but now I have a nice point at 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. That is my nice, pretty star point. I have some other points, and they are about right here. It's at 1 1/5, or 1 and 0.2. And then my 2 is not quite 1. And then 3 is just under 2. And then 4 is just over 3. So it looks something like that. And I connect all of these nice points, and that is for, oops, my lead broke. Oh, bother. I'll switch to red. So that is for my a equals 1/5. And I have to go the other direction too. So hopefully you're noticing that one side of the graph mimics the other side, right? They're mirrors of each other. So this one is a -1 and 1/5. And then I've got -2 and just under 1, and then -3 and just under 2, then -4 just over 3, and -5 and -5. So it looks something like that. What do you think is going to happen when we plug in our -1/5 into Desmos? What do you think is going to happen to that graph that we just made? Well, let's check it out and see if you're right. So our vertex is still here, but now we've got 1 and -1/5, 2 and almost -1, 3 and just under -2, and then I'm going to do my 5 and my -5. So there is one side, the a equals -1/5. And we also have the other side. All right. There we go. So let's see if we can put together some of what we've just discovered. Right? Let's see if we can kind of summarize some of what we just discovered. We know that for quadratics, right, because here's our quadratic right here, it's either going to open up in a smiley face, or it opens down in a frowny face. We always read graphs just like we read English. So we always read graphs from left to right. Right? We read from left to right. So that means for this part right here, because we read from left to right, that means that it's going down, it's decreasing, and then on this side, it's increasing. So we have a decreasing over here and an increasing over here. So it switches, so to speak. We also know that these graphs have what's called an axis of symmetry. All right, axis of symmetry. It means that it's the exact middle. Right, it's the exact middle. Another way of thinking about that is it's the mirror point, right? The mirror, this is where the mirror would be. So this side looks exactly the same as this side. You could fold it in half, axis of symmetry. In this case, this one actually has an axis of symmetry at the line x equals 3. If we think we way back, this vertical line here touches the x-axis at 3. So the axis of symmetry for this quadratic is at x equals 3. This is, like I said, a vertical line. It's a vertical line. And it's important to note that this goes through the vertex. All right, it goes through the vertex. Now the vertex is a very special point. It is right here. So that is the vertex. The vertex is where it switches from decreasing to increasing, all right? Another way of thinking about it is it's either the lowest that the graph will go or it's the highest that the graph will go. So the vertex is very, very important. Another way of thinking about it is it's the tip. And we said it's the lowest point, and we call that a minimum, or it's the highest point. In this case, we can actually read what this vertex is. This vertex is at the point 3, 1. That is the vertex for this one. The last thing that we can look at and we can talk about is the domain for this graph and the range. All right. So for the domain, remember domain is all possible x values. So when we look at this, we have an arrow right here, which means it keeps going and going and going to the right. So that means it's going to touch every x possible to the right. We also have an arrow over here. That means it keeps going to the left, going and going and going. So if it keeps going all the way right and all the way left, that means the domain is all real numbers. For all parabolas, this is the case. The domain is all real numbers for all parabolas. Well, let's take a look at the range then. There's actually a limit because we have a lowest point or a highest point. There's actually a limit on our range. Remember, range is all possible y values. So the range is either going to start or end where our vertex is. And it can either go everything above it or everything below it. So we have to determine if we have a lowest point or a highest point. In this case, because it opens upward, we have a lowest point, so we have a minimum. So for this one, our y is going to be everything greater than or equal to, well, what's our y value here? Where is our line that we do not go below? It's at 1. So y is going to be greater than or equal to 1. That is our range. So on the last page, we were looking at all the different a values and what it did to the graph. let's summarize what those are just a little bit. So the question is what? I'm going to slide this up. What did we notice about a in f of x equals ax squared plus c? What did we notice? One of the things that we saw is that when the absolute value of a is less than 1, so this is when it's a fraction, right? When the absolute value of a is a fraction, then it got wider. We call this a vertical stretch. Sorry, vertical shrink. Vertical shrink. Excuse my dyslexia. So it gets wider. It looks more like this, right? It gets wider. Another way of thinking about it is it got closer to the x-axis. That's another way of thinking about it. Well, what about when a was greater than 1? So that was when we had 5 and 10. Then it got narrower, right? It got narrower. So it looked more like this, like a V or a U. We call this a vertical stretch. It goes up really, really fast is another way of saying it. Well, what about when a was positive? It opened upward, right? It was a smiley face. That was when we had 5, 10, 1/2, 1/5. And when a was negative, it was a frowny face. It opens downward. It opens downward. So that was everything we noticed about A, or we should have noticed about A. Let's take a look at what we think will happen with not actually plugging it into Desmos and just looking at the function and being able to say whether we think it's going to open upward or downward, or if we think it's going to be wider or narrower. All right, let's just try that out. So we're going to order the functions from narrowest to widest. Keep in mind that the absolute value of a, the larger a, that means it's a stretch. So it's going to look more like this. And the smaller the a value, then that's a shrink. So it's going to be that wider, right? So keep that in mind. With our first three here, we've got f of x equals negative 2x squared, 1/3 x squared, and 4x squared. So we're comparing all of those. Well, if we look at our a values, we have a -2, a 1/3, and a 4. Now we want the absolute value of a. So we're going to change this -2 into just a 2. And then all the others are positive. So this would be their a values, and this is their absolute a values. We have to ask ourselves, which one is the largest? Which one is the largest a? Well, that would have to be the 4, which is h of x. So that has the largest a. That means that one is the narrowest. It's the narrowest. Which one has the next largest? That would be 2, so that would be f of x is next. And it's a little bit wider. Not by much, but a little bit. And then which one has the smallest? Well, the smallest is our 1/3, which is g of x. So this one's going to be a super wide function compared to the other ones. So narrowest to widest, that's what we would do. All right, I want you to pause the video here, try the next 3. Pause the video here, try the next 3. Okay, so for f of x, for this one, we know our a value is 2, And for g of x, it's negative 2. When we take the absolute value of that, we have 2 and 2. So which one's narrower? Neither of them. They're the same. They're the same width. Because absolute value of a is the same. All right, what about for f of x equals negative x squared and g of x is 2/3 x squared? There's actually a ninja number here, right? Negative x squared is really an a value of negative 1. And then g of x has an a value of 2/3. So which one is bigger? Which one is bigger when we take their absolute value? 1 or 2/3? Well, the 1 is. So that means that f of x and then g of x is how they go from narrower to wider. All right, our last one down here. We have our a values of negative 4, 6, and 0.2. The absolute values for those would be 4, 6, and 0.2. Well, which one is the biggest? 6. So that means g of x is going to be the narrowest. Which one's the next biggest? 4. So that means f of x would come next. And then which one has the smallest and is therefore going to be the widest? H of x. So there's our answers. And you couldn't even see that. I apologize. I apologize. I will leave this screen up for a second, so hopefully you can see it now. All right, this is going to be it for day 1. Okay, this is going to be it for day 1. I'm going to do some more, and we'll look at that C term next. So pause the video here if you would like to, so you can work on your skills practice. All right, welcome back to 8.1, 8.2, and this is day 2. So yesterday we looked at the value of a, right? Ax squared and what a did to the graph. If it was positive, if it was negative, if it was a big number, or if it was a fraction or less than 1. Today we're going to look at c. All right, we're going to look at c. So let's start. Again, you will want lots and lots of colors. Okay, lots of colors. So let's start with our c equals 5. And our c equals negative 5. And of course, my orange, yet again, breaks on me. Classic. All right. C equals 5 and c equals negative 5. So if c is 5, when I plug in into Desmos, we've got x squared plus 5, right? So f of x equals x squared plus 5. And remember, this f of x, it means y. Just reminding ourselves we know that. So it looks like my graph starts at 1, 2, 3, 4, 5 on the y-axis. And then my next point is 1, 6 and negative 1, 6. So my graph for when c is 5 looks something like that. And then when c is negative 5, my graph starts at 1, 2, 3, 4, 5 on the y-axis. And then I have a 1 and negative 4 and a negative 1 and negative 4. And then I have another point right about here. There we go. Again, make sure that you've got a nice curve at the bottom. All right. So that is our c equals negative 5, something like that. Again, yours should go from edge to edge. Don't forget to have it to go from edge to edge. Sorry, it was a little off, wasn't it? All right, let's look at our next one. If we have a c of 2 and a c of negative 2. Well, for 2, looks like I'm starting right about here. And then my other points look something like that. So this is for a c that's 2. If I have a c that is equal to negative 2, then my points are down here. So they look something like that. And that is when c equals negative 2. All right, our next one is when we have a c that is positive 1/2 or negative 1/2. Well, so for positive 1/2, it's right about here. So it looks something like that. Again, make sure that that vertex, that lowest point down here, is a nice curve. And then when it's a negative 1/2, it looks something like that. And that is our c equals negative 1/2 down here. And then our very, very last one, I'm going to do in yellow. Sorry if that's a bad color, but I'm running out of color options. So our last one is c equals 1/5 and c equals negative 1/5. So for positive 1/5, it looks something like this. Right, that's my c equals 1/5. And then for negative 1/5, it's just below the origin. And it looks something like this. That's our c equals negative 1/5. So what happens when we change our c value? We go from 5 to 2 to 1/2 to 1/5 to negative 1/5, negative 1/2, negative 2, and negative 5. So as c gets smaller, the graph moves down. Or as c gets bigger, the graph moves up. It just shifts it literally up and down, right? And hopefully my Desmos is working and we can kind of see that right next to this. So on our next page, here we go. We learned that c, just now we learned that c has, is the y-intercept, right? It's where the graph touches the y-axis. If it's a positive c or if c gets bigger, it moves up. If you have a smaller c or it's negative, it moves the graph down. Let's remind ourselves from yesterday, or from day one of these notes, right? From the other day, we had an absolute value of a. If it was bigger than 1, then that was a vertical stretch. So another way of saying that is that it was skinny or it was narrow. Another way of thinking about it is it rises fast, right? If we had an absolute value of a that was less than 1, so if it's a fraction or just a decimal like 0.2, then it's called a vertical shrink. So these were ones that were fat, or another way of saying that is they rise slow. It's a different way of saying it. When we had a positive a value, the graph opened upward, right? It was a smiley face. If you want to write smile on there, that's fine. Smile. If it was a negative a value, then it was a downward opening. Another way of thinking about that is it was a frown or a sad face. Maybe I've been hanging out with toddlers too much to say sad. So let's take a look at how this can help us. All right, we know that the simplest function, or the parent function for a quadratic, the one that we start from, is this f of x equals x squared. This is the starting point for every quadratic function. It's the most basic form of a quadratic function. So if we know about a, absolute value of a, and c, we can just look at an example like this g of x, and then based upon what values of a, absolute value of a, and c are, we can talk about what the graph is going to look like without even having to plot it. So let's just look at the absolute value of a. All right, that's the first one we'll look at. The absolute value of a, well, a we know is 1/3. So the absolute value of, negative 1/3. The absolute value of negative 1/3 is 1/3. So that's the absolute value of a for this graph. And we just said that if the absolute value of a is less than 1, and 1/3 is less than 1, so it must be, I will slide this up to say a vertical stretch. Vertical stretch. So this, no, I had it right, shrink. Oh, silly Miss Frisch. So this is one that's going to rise slower. It's going to be wide, right? It's wide. Wide. So then let's take a look at just what a is. And we know a is negative 1/3. Now, if it's a negative a, that means it's going to open downward. So this is a downward opening. And then the last one is c. Well, the value of c is this positive 2. So we know if c equals 2, then its y-intercept is at 0, 2. If we compare it to our parent function, to x squared, then we would say that it has been moved up 2. So let me erase these lines a little bit so we have room to write down here. We know that g of x is 2 higher. I shouldn't say it that way, sorry, is moved 2 up, moved 2 upwards, opens downward, and has a vertical shrink compared to f of x equals x squared. That's what we know. We know it has a vertical shrink, it opens downward, and it has been moved 2 upwards compared to f of x equals x squared. So the next thing I want us to try, there are 3 more examples on the next page. Pause the video here, turn the paper over, and try those next 3. We're going to go over the answers in just 1 second. Pause the video and try those next 3. Talk about the absolute a value, and c. How is the graph going to change? All right, you should pause the video. We're going to take this one at a time. So our first one is g of x equals 2x squared minus 3. Our absolute value of a is 2, so that's a vertical stretch. It's a vertical stretch. A is 2, it's a positive, that means it opens upward. And then c is a negative 3. Remember to keep that negative with the 3, right? So it's been moved 3 down. So g of x is moved 3 down, opens upward, and is vertically stretched. The next one is g of x equals negative x squared minus 4. The absolute value of a is 1, right? There's a little ninja 1 in there, negative 1. So absolute value of negative 1 is 1. Because it's 1, it doesn't have a stretch or a shrink. All right, it doesn't have a stretch or a shrink. It's going to be exactly the same width as x squared. But a is a negative, so that means it opens downward. Our x squared here, our f of x, still opens upward. And then c is a negative 4, so it's been moved down 4, or the y-intercept is going to be at negative 4 in this case. And then our last one, for g of x equals 3x squared plus 9. The absolute value of our a, which is 3, is bigger than 1, so it's a vertical stretch. And then we have a positive 3 here, so it opens upward, and a plus 9, so that means the graph has been moved 9 up. So g of x is 9 upwards, opens upward, and is a vertical stretch compared to f of x equals x squared. Please email me if you have questions about any of this, all right? This is extremely important. You're going to see it all through Algebra 2. The skills practice is posted to Big Ideas.